Hello everyone, in this video we are going to talk about transformations of quadratic functions. So if you're working on Study Island, Algebra 1 quadratic function transformations, we will learn how to do vertical compress or vertical stretch. We will then learn about, translating the graph either horizontally or vertically. Lastly, we are going to learn how to reflect a function, a quadratic function, over the x-axis. So let's get started with the first example. It tells us that our original function is y equals f of x, and then it asks us to choose the correct form of transformations based on the second equation we have. So basically y equals x squared. Let me just use basically y equals x squared turned into y equals 1 over 6 times x minus 4 squared plus 6. Now let's talk about each of these numbers one at a time. So I want to start with let me see, the multiplication. So let's see which one. Okay, let's start with 1 over 6 times. So when we multiply that original x squared by 1/6, that tells us either vertical stretch or vertical compress. It's either one of them, okay? So let's see how we will decide that. So when we have this number over here, it could be a whole number, it could be a fraction. What that number describes is that it tells you whether you have a vertical stretch or compress. So let me use this space over here. It's either vertical stretch or compress. So you have vertical stretch when the numbers are bigger than 1, positive 1, such as 2, 3, 10, or 11 over 2. They could be fractions or whole numbers, doesn't matter. They express vertical stretch. What that means, the graph is going to look, let me see, it's going to get narrow, okay? If this was the original graph, when we do vertical stretch, it'll look like this, okay? So for the vertical compress, if your number that you multiply the x squared by is between -1 and +1, if it is between -1, if that number is between these two, then you have vertical compress. What that means, from the top and bottom of the curve, compress the graph. It'll get wider. So the arms of the curve is going to get wider when you compress from the top and from the bottom. So those numbers are positive 1/2, -1/2, and then 1/3, -1/3, 5/7, or it's negative. So all these numbers expresses vertical compress. So the number we have is 1/6. It is in between -1 and +1. So we are dealing with a vertical compress. It's going to get wider. When we compress the curve from the top and bottom, the arms are going to get wider. So our answer is not going to be vertical stretch. So we cross those two out. It's either A or C. I also want to show you how it looks like when we graph it on the coordinate plane. I want to show you a comparison between y equals x squared, which is right here, the red curve, and then let's see what happens if I multiply this by 1/6. It gets wider because from the top and bottom, it's like we are compressing the curve, and then the arms are going to get wider. When you multiply it by a number that is in between -1 and +1, the fractions are going to look like these. Okay, so let's get back over here, and now let's talk about the number we add in the end of the function. So the number we add in the end is +6. So what this number does is it either moves the graph up or down, translating it up or down. That's what you're looking for. With the 6, the word that we want to see is either up or down. And this is pretty straightforward since we are adding that number to the whole function. It's like changing the y value by positive 6. So it's going to increase the y value. It's going to take the graph, because if you think about the coordinate plane and on the y-axis, let's just draw the coordinate plane over here and then talk about the y-axis. Since when you add a number in the end, like positive 6, you are changing this because it's changing the whole thing. Your y is equal to x squared in here, and then if you do this, you're increasing the y value by 6. So when you increase the y value by 6, what happens is the graph x squared originally is going to be up here, passing through the center, a curve like this. When you move this up 6 units, it's going to be a curve passing through positive 6. So that's positive 6. Basically, what that number tells you logically is your answer. Positive numbers on the y-axis are all up here in this area. When you see a positive number, that tells you to lift it up. So examples for this kind of a movement are if you see positive 3, positive 5, even like positive 1/2. That's fine. Examples that tells you to move it down are negative numbers, any negative number. Negative 2, negative 2/5, negative 1, or any other negative numbers. Could be a fraction, could be a whole number. So now we are looking for something that says up 6 units in the answer. We know B is not our answer, D is not our answer. This one says 6 units to the left. This one says up 6 units. So C is going to be my answer, but before moving on to the next question, I also want to talk about what that negative 4 does. This is not subtracting 4 from the whole function. It is subtracting the 4 from the x. That's why they're together in a parentheses. X minus 4 tells you to subtract 4 from the x. So when you subtract a number from the x, that means we are talking about the x-intercept. And we are talking about this right here. It's horizontal movement. When you start dealing with horizontal movement, put your logic aside. And then technically, negative 4 is like, since all of the negative numbers are on the left side of the x-axis, you might think like, okay, this should be left 4 units, but do the opposite of what you think is the right thing when you start dealing with a horizontal movement. So this one here seems to be like negative 4 and left 4 units, but it's going to be the exact opposite. So it's either right or left. When we add or subtract a number to the x or from the x, positive numbers means left, positive 1/3 or positive 10, and negative numbers are telling you to translate it to the right. So we have a negative number. That means we are dealing with right 4 units. So this right here is the one that we are looking for, so that would be our answer. Okay, so try to take notes by pausing the video, because if you just throw these arrows and then use the keywords that I had with the different colors, then at least you will know that which number represents a vertical movement, which number represents a horizontal movement, or which one represents a stretch or compression. Now let's move on to the second question. Now that we have a general idea about what the numbers represent, we can get quicker to the solution. So our original expression is this. What happens is, how will the graph of gx differ from the graph of f of x? So gx tells us to add 3 to the whole function. So that's what that means. Add 3 to the function. So when you are adding a number to the function, this is vertical movement because the number is in the end of your right side. So just like the other vertical movement, this is vertical, or let's just, since it's added in the end of the function, it is up 3. If you were doing this right here, is changing the x. It's not changing the whole function, and we are doing negative. This is horizontal movement. We are changing the variable, the x. That means to think about the opposite of what you think is the right thing. This looks like it is left 3 units, but now it's right 3 units. That's the difference between f of x minus 3 or f of x plus 3. So adding a number to the whole function versus subtracting or adding a number to the variable. That's the difference between vertical and horizontal movement. You might want to write it down as, let me just, okay. Add, subtract to the function. This represents a vertical movement, up or down. If you're just affecting your variable, just the x, then you are talking about add, subtract to x or from x. Then you're talking about a horizontal movement. If you see subtraction for horizontal, that means move it right. If you see an addition to the variable, that's talking about translating to the left. Okay, now this one here is shifting it up 3 units. It's, which one is it? This right here, A. Okay, moving on to the next question. Question number 3. Now let's talk about what is going on in here. So instead of trying to figure out what's going on with the curve, try to figure out what is going on between the vertices. So this one here is the top point of the original graph, and then it gets back over here. How would you describe this? It's like take this point and then move it left 2 units, right? Left 2. This is horizontal. It's just about changing the variable. You're not going to subtract 2 in the end, because that would mean a vertical movement up or down. So when you have right or left, you just want to change the variable. Look at the options and see which one is just about affecting the x. So this right here is added to the whole thing. It's not just affecting the x. And this right here is affecting the whole thing. This is down 2 because they are subtracted from the end of the function, and then this is up 2 because it's in the end of the function. And in A and B, we are just changing, modifying the x. The first one says subtract 2 from the variable. So when you deal with horizontal movement, you think about the opposite. So this one here is right 2 because it's a negative number. Normally it would mean like left, but think about the opposite of what you think is the right thing when you deal with horizontal movement. And this right here tells us to move it left 2 units. So looking at what is going on in here, we were moving it left 2 units, so this is my answer. Okay, so moving on to question number 4. Okay, this right here is either vertical stretch or vertical compress, because this point, the vertex is the same. We didn't move it left or right. We are not going to add a number. We are not going to subtract a number. So that's gone. What this means is, I hope you see what that means. That's a horizontal movement because we are just altering the x value. It's positive. That means we are talking about moving it left 1 unit. So all of these are talking about the same thing, because all those fractions, 1/4, 1/2, and then 1/16, they are talking about the same vertical, either compress or stretch. Now, think about what you need to do to get the second figure that looks wider. You need to compress it from the top and from the bottom, right? So all of these represent a vertical compress, but how do we decide which one is the right one? So for this, you need to pick a point on the second graph and plug it in to see which one of B, C, or D is the right answer. So you gotta choose a point that you can decide what the coordinates are, such as this right here. That's the only point that I can see on the right side of the graph. The coordinates are 4 and 1. X equals 4, Y equals 1. So now you need to plug these numbers in and see which one is going to be the right one. I see which one is the right one, so I'm just going to plug it in to that one over here. Let's just rewrite this. It's y equals 1 over 16 times x squared. And then I'm going to plug in, let's do substitution, x for 4, or 4 for x, and then square this. And see if the answer is going to be that number, okay? So that's 1 over 16 times 16, and then these are going to simplify each other. The answer is going to be 1. So y equals 1, and it was supposed to be 1. That means this is my answer. I also want to show you how it will look like if you were plugging it in into a wrong equation. Y equals 1 over 2 times x squared. Let's plug in 4 for x and see what happens. Let's see if we are going to end up with 1. This one is 1/2 times 16, and when we simplify these two numbers, that one is going to turn into 8. The answer is going to be 8 for y. We did not end up with 1. That's not the right answer. So that's what kind of an equation you would see if you substitute that x value in a wrong equation. So this one is D. Let's move on to the next one. Question number 5. I see what is going on. The center, the vertex of the graph, the quadratic, moves from here to here. This is like down 1 unit. That means you need to subtract 1 from the whole function. Subtract 1. But you don't want to make it like, you don't want to see something like this in the answer, because this is wrong. What this means is write 1. Because this is not subtracting 1 from the whole thing. It is just subtracting it from the variable. That represents a horizontal movement. When you have x squared minus 1, this represents a vertical movement. That means down 1. So that's what you're looking for in the answer, this right here. That's right 1. This one here is up 1. This one here is left 1. Just so you see what they mean, I wanted to answer each one of those answers just to make sure you have enough examples. Again, just want to reiterate that when you add or subtract a number from the x, you're talking about right or left. Just keep that in mind. If the number is in the end, you're talking about up or down. If it is multiplication, then it's either vertical stretch or vertical compress. Right here, the next one. Question number 6 and 7. Let's do them together. Okay, this right here is just affecting the x. It's horizontal movement. X-axis is horizontal, either right or left. Positive 7, logically, you might think that it is on the right side of the x-axis, but remember, when you think about the horizontal movement, do whatever you think is the right thing. So this one looks like it's positive right 7. No, it's going to be left 7. So shift it to produce the graph. In which direction must the graph should be shifted to produce that one? It should be shifted left, 7 units. And then question 7. Okay, let's check that one out. We have y equals x squared. We multiplied it by 2. We subtracted 5 from x. That means right 5 units. And then this right here is in the end. That is down 9. And this one here. Okay, let's see. Right 5, down 9. Right 5. This is not my answer. Not my answer. To the right, to the right. So, is it going to be vertical stretch or compressed? Now, that's the question. So, y equals x squared. Y equals 2 times x squared. It's going to get narrower, so it'll be a vertical stretch. Yeah, it'll be a vertical stretch. The green graph, okay. So this one here is going to be a vertical stretch. I was about to do this one wrong. Okay, vertical stretch right here. Next one is question number 8. Reflected across the x-axis. Okay, This is the first reflection question. I was going to skip this, but let's do it. So when we have reflection across the x-axis, what you do, you basically switch the sign of everything in your equation. Switch all of the signs. You will usually have just one x squared. That's it. Most of the time, that's how the graph is gonna, the equation is gonna be, and then you're gonna turn it into negative. If it's given as negative, you'll turn it into positive. So this right here is your original function, y equals x squared. When you reflect this across the x-axis, all you do is go to your right side, change all of the signs. You have only one term. It's positive, just turn it into negative. That's it. That's all you do. You add a negative in front of everything. So that would be the answer. Reflection across the x-axis on IXL study island, usually this is going to be the only equation you're going to have. If you have a reflection across the x-axis, probably this is going to be the original function that you have, and the answer is going to look like this. Okay, moving on to the last one. I don't think I want to do number 10. I haven't seen that question. Let me see. Okay, that's translating it. So let's do this vertical question. Vertical stretch or compress. Now the graph of the function is vertically shrunk. Which of the following represents the graph on the right? So if it's getting wider, right? So we are compressing the graph from the top and from the bottom. We are looking for a fraction between -1 and +1. That's what I need. So not this one, not that one. Again, when the graph gets fatter, then you're looking for a fraction between -1 and +1. So it's either one of these two, A or B. Now pick a point and plug it in. So if my x value is 2, the y is going to be 2 according to the graph on the right side. So this is the right one, I can see it, so I want to choose that one and then plug it in. Y equals 1/4 times x, that's my x value that I will substitute, squared. So 1/4 times 2 squared is 4. You can simplify those two. The y value is going to be 1. Oh, that's not the answer then. Okay. I don't know why I thought that was the answer. Let's do the same with this. Okay, y equals, I don't think writing with yellow on white is a good idea. Okay, so y equals 1/2 times 4 squared. Neither one of them look right. What did I do wrong? Interesting. Let me stop the video because I don't want you to look at me when I'm just staring at the question. Let me figure this out. Okay, I'll pause the video for a second. Okay, I just see what was the problem. The problem is the number that I plugged in over here. I was supposed to plug in 2 because that was the x value. Let's just get back here. Come on. Okay, almost. Okay, let's plug in that number. So it was 2 because that's my x value, and I want to end up with 2 for the y, and then square. Okay, 1/2 times 4. Simplify these two numbers, they'll turn into 2 for the y. So when I plug in 2 for x, I get 2 for y. Basically, this is going to be my answer. So the video took about 30 minutes. Sorry about that. It was a long assignment. So that's how you do your translation, reflection, and vertical stretch or vertical compression. Thanks for watching. Let me know if you have any questions, and I will see you in another video.